Hello future engineers and my dear students, welcome back to Mudasar Academy and also welcome back to another important session on L'Hopital's rule. In the previous video, we covered basic solving limits involving standard functions and trigonometric functions like sin and tan x, where we use the standard key limits like limit of sin x yx as x tends to 0 is equal to 1 and also limit of tan x yx as x tends to 0 is equal to 1. If you haven't watched the video yet, then please find the link in the description below and please go and check it out. In previous problems, we solved indeterminate forms like 0 by 0 or infinity by infinity. Now, today's final and most crucial part, we will be learning to handle indeterminate forms like 0 raised to 0, infinity raised to infinity, 1 raised to infinity, etc. These appear in problems like limit of x tends to a f of x raised to g of x, that is a function raised to a function, which can't be solved directly using the basic L'Hopital's rule. So, we will be using logarithmic transformation and solve some actual exam related questions together. This is one of the most commonly asked type questions in semester and examinations. So, don't skip this video, watch till the end and stay focused. And if you haven't already, then please subscribe to my channel and share the video with your friends and classmates as much as possible to help me reach more and more students and continue spreading knowledge. Every view and share really means a lot. So let us solve L'Hopital's rules, very important examination based questions which are of the type 0 raised to 0 or infinity raised to infinity and 1 raised to infinity form. So let's start by solving this question. Evaluate the limit as x tends to pi by 2 sin x whole raised to tan x. So this is what form? Function raised to function. So, what is the first thing we do while applying the L'Hopital's rule? As I always keep on telling you in previous videos also, first is assign k. See, solving mathematics problems is a discipline. So, follow the discipline, you get the right answer. So, first thing what we do is assign k to the question. So, we have k is equal to limit as x tending to pi by 2 sin x whole raised to tan x. So, now let's check the limits here. Apply the what is the limit here? X tends to pi by 2. So what is sin pi by 2? Sin 90 is 1. 1. And what is tan pi by 2? What is tan 90? Tan 90 is always infinity. Sin 90 is 1. Tan 90 is what? Infinity. See, we get a form. 1 raised to infinity. Okay. So the type is correct now. Now what to do? As we discussed in the first video also, while I was giving the introduction of L'Hopital's rule, and such problems of the form of 0 to 0, infinity to infinity or 1 is to infinity, in solving such problems we have to apply the logarithmic transformation, because log has the power to bring anything down. Getting it? I always keep on repeating, log is a very powerful tool. It can bring any function down. How? This is a very important logarithmic relation, that is log of a raised to k equals k log a. What is that? Log of a raised to k is equal to k log a. So what I do here first? Apply log on both sides. When you apply log here, log of k is equal to limit as x tending to pi by 2 log sin x whole raised to tan x. Because to solve the L'Hopital's rule problems, we need a fraction form, numerator over denominator. We don't need, see, to solve any standard questions, multiplication, division, raised to power is not allowed in mathematics. Okay, that's why when you apply log a raised to k is k log a. That k comes down. Okay, now we have it till here. So, what is that? Log a raised to k is equal to what? K log a. So, log a raised to k log a. So, this will be now log of k is equal to limit as x tending to pi by 2 tan x into log of sin x. Why? Because log a raised to k is k log a. K is tan x into log sin x. Again, to solve any L'Hopital's rule, we need a fraction. You have to use your brains here now to make this thing a fraction. Okay, the power is gone. Now, your main aim is to make it a fraction. How? Very simple. Log sin x, I cannot do anything. So limit as x tending to pi by 2, log of sin x as it is. But tan x, I can write tan x as 1 by cot x. 1 by cot is tan. Very simple trigonometric relation. 1 by cot is tan, 1 by tan is cot. So tan x is written as 1 by. Now to check, let's again apply the limits. So what you get? Sin pi by 2 is what? Log 1. Again, cot pi by 2 is what? 0. Why? Because see, tan pi by 2 is infinity. So cot pi by 2 is 1 by cot. 1 by infinity is 0. Remember this, you can memorize this. Tan pi by 2 is infinity, cot pi by 2 is 0. And log 1 is 0. So we get 0 by 0 form. So we can happily apply the L'Hopital's rule here. So what does the L'Hopital's rule say? Differentiate the numerator and denominator separately. So we have this as log of k is equal to limit as x tends to pi by 2. So by L'Hopital's rule, I read a short form LHR. Okay. So log of sin x. Log of sin x. Differentiation of log x is 1 by x. So log of x is only 1 by x. Log of sin x is not standard again, differentiation. You shall not thorough with this. Please see it carefully, here carefully, and see it here. Log of sin x. First who comes? Log. Differential only log of x exists. Log of x is 1 by x. So this will be 1 by sin x into again chain rule differentiation of in place of x. What is there? Sin x. Differential sin x is nothing but upon what is the differentiation of cot x? Differentiation of tan x is secant square x. Cot x is minus cosecant square x. Listen carefully. What is that? Minus cosecant square x. So this will be again now limit as x tending to pi by 2 cot x by minus cosecant square x. Now when we have trigonometric relations, let's make this thing simpler. How? Because I will write this again as, see this, I will write this again as limit as x tending to pi by 2. Now see cot x. Again see, I rewrite cot x as cos by sin, cos x by sin x. Okay, upon minus cosecant square x. Sin 1 by sin is cosecant. Getting it? 1 by cosecant is sin. So cosecant square is what? 1 by sin x. What is cosecant? 1 by sin. Remember it. Cosecant is 1 by sin is 1 by cosecant. So this is the cosecant square. I will write it as this is 1 by sin square x. Okay. So minus there, minus 1 by sin square x. Now here, what happens is that 1 sin and 1 sin cancels. 1 sin, 1 sin cancels. Okay. So what I get here? This will be now, see, cos x by 1 by sin. They go up. So we have this as log of k is equal to limit as x tending to pi by 2. See, cos upon sin. So they cut. Cos by 1 by sin means it will be cos x minus sin will be there because there is minus sign here. Okay, minus cos x into sin x. Why? Because simple mathematical transformation. What happens here? Cos as it is, cos divided by 1 by sin. So 1 by 1 by sin goes top. So cos into sin. Now again, that implies we have log of k is equal to, what is cos pi by 2? 0. Sin 90, sin pi by 2, 1. 1 into 0, 0. Getting it? Again see, apply the limit here. F tending to pi by 2, cos pi by 2 is how much? 0. Sin pi by 2, 1. 1 into 0 is 0. So log k is equal to 0. That implies when log k is equal to 0, k is equal to e raised to 0. That means what is e raised to 0? 1. So the solution for this question is k is equal to 1. That's it. As simple as that. I hope you understood how to solve this. So the next very important question which we are going to solve here is Evaluate limit as x tends to 0, bracket tan x by x whole raised to 1 by x square. See, this question is also function raised to function form. So, what is the first thing we do here? Yes, assign k. So, we write k is equal to limit as x tending to 0. We have bracket tan x by x whole raised to 1 by x square. So, after that, we apply the limits here. You know, tan x by x to 0 is equal to 1 and 1 by 0 is what? Infinity. Again 1 raised to infinity form. So, this will be again employing the logarithmic transformations. Okay. So, what to do here? First apply log on both sides. Log of k is equal to limit as x tending to 0 log of tan x by x whole raised to 1 by x square. Okay. Again, why do I apply log? I keep on repeating this again and again. Listen, keep on listening to my words carefully. Keep on listening to this video again and again. My words are designed to enter and fit in your brain so that you don't forget. Again, log e raised to k is what? K log a. I keep on reminding you this. Log has the power to bring anything down. So, here, when I apply log a raised to k, this is a and this is k. This is a raised to k. So, that will come down to become log k is equal to limit as x tending to 0. This will be log of tan of x by x into 1 by square, that is upon x squared. So, we got a fraction form here now, for which you can apply the L'Hopital's rule. Now, let us see, apply it. So, again log tan 0 by 0 upon 0. So, we get log infinity, right? If I apply 0 here, so tan 0 by tan 0 is 0 upon 0, log of 0. What is log 0? Log 0 is infinity. Sorry, we get when I apply 0 here, when we apply 0 here, tan 0 by 0. 0 by 0 is what? Infinity. And log infinity is what? 0 upon 0. That means I can apply the L'Hopital's rule here happily. So, what does it say? Differentiate the numerator upon differentiate denominator separately. This is separate, this is separate. So, by what? L'Hopital's rule, LHR, as a short form, we can write log of k is equal to limit as x tending to 0. See, differentiate the numerator separately. Log of tan x was changed. Differentiation of log x is, listen carefully this differentiation if you are not aware of it. Log differentiation of log x is 1 by x. Apart from x, again something is there, then again differentiate it, that is changed. Only log of x is 1 by x. So, log of tan x by x is 1 by tan x by x. I write it first. This will be equal to 1 by tan x by x. Fine. Into again. First, log of x is 1 by x. Again, in place of x, what is there? Tan x by x. So, differentiate again tan x by x. For this differentiation, we use what? Tan x by x, we use the quotient rule. I will write again for you if I have forgotten. Differentiation of first by second function is equal to difference is equal to what? Second function square. Okay, second function as it is, differentiate first, minus first function as it is, differentiate second. This is the quotient rule in a very, very simple form. Okay, now if you apply this rule here, see, tan x by x, differential log x 1 by x, 1 by again differentiation of tan x by x will be x squared square, see numerator, x as it is, differentiation of tan x is what? Secant square x minus tan x as it is, differentiation x is 1 whole divided by differentiation of x square, denominator is what? X. I have understood the differentiation here. Now, what will do next? See, I am getting a formula tan x y x. We discussed in the previous video. Limit as x tends to 0, tan x y x is equal to 1. So we have here, what's that? Limit as x tending to 0, tan x by x equals to 1. So we apply the limit here, then this will become what? This becomes 1. Gone. So stuff is gone here. Right. So this you can rewrite this as, let's simplify this. Limit as x tending to 0, x secant square x minus tan x whole divided by 2x into x square 2x cube. Fine. This is what I get. Now again, if I apply limit to this, 0 secant 0 1 0 0, 0 minus tan 0 0 upon 0. Again 0 by 0 indeterminate form. Again apply the Spital's rule. It is again differentiate numerator upon denominator separately. So we write this as replace log of k is equal to again limit as x tending to 0. See differentiation here. I cannot reduce it anywhere. So here x into secant square x is a product tool. What's product tool? First function as it is, differentiate second, plus second function as it is, differentiate first. The first is x, second is secant square x. Now see carefully. X as it is, differentiation of secant square x. X is t n is n x to n minus 1. Secant square x will be 2 secant x. Again the chain rule. 2 secant x. Again the chain rule. Again differentiation of secant x is what? Secant x into tan x. Okay, I write it here. Secant x into tan x. Are you getting it? One more time. X as it is, secant square is 2 secant x. Again secant x will be what? Secant x into tan x differentiation. Plus secant square x as it is, differentiation x is 1. If x is 1, done. X into secant square x differentiation done here. Now minus again, what's the differential of tan x? Nothing but what? Secant square x whole divided by what is differentiation of 2x cube? Is nothing but what? 6x square. 6x square. That's it. Now here again what happens? See, plus secant square minus secant square cancels. So what remains? Get this as limit as x tending to 0, 2x into secant square x, 2x secant square x into tan x whole divided by what? Whole divided by 6x square, right? 6x square. Now here many things cancels. Which are things cancels? Tell me. See, first 2x into secant square x tan x upon 6x square. Now x and x cancel, 2 ones are 2, 3s are. Right? So what I will write this as now? So log of k equals limit as x tending to 0, secant square x into, see x cancels. So this will be tan x divided by x. Okay, 2 and the 2 3s are upon, right? Okay, upon. Now, as you know, this factor again, see, tan x as x tends to 0 is nothing but what? It's what? Limit of tan x as x tends to 0 is always 1. Done. Now, secant 0, now put the limit again. That implies log of k is equal to, in place of x put 0, secant 0, cos 0 is 1. Cos 0 is 1. So, cos 1 by secant is cos, secant 0 is also 1. Remember it, cos 0 is 1, secant 0 is also 1. So, secant 0 is 1 here, so 1 by 3. So, log k is 1 by 3. That implies k is equal to what? The value of k is, for this question is e raised to by 3. That's it. This is the answer. Okay, I hope you understood how to solve it. There is a lot of differentiation work, question truths, product truths here. So that only comes by more and more practice. I hope You will do it. See, the next question here is evaluate limit as x tends to 0, a raised to x plus b raised to x plus c raised to x whole divided by 3 whole raised to 1 by x. Trust me, this question is very, very important. It has been asked several times in the examination. Okay, and chances are that this time also in the same examination they may repeat the same question. So, please watch carefully how I solve it. The better is that you take down your notebooks and pens and solve with me till the end and see how it is done, so that you don't miss any steps and get the full marks. So, the first thing what to do, always assign k is equal to. Okay, so let's begin it. K is equal to limit as x tending to 0, a raised to x plus b raised to x plus c raised to x upon 3 whole raised to 1 by x. As this question carries around 6 marks or 7 marks, you have to carry, then you have to write each and every step properly. Now, first let's apply the limits. See, if you apply the limits here, this will be again, what is that, a raised to 0, what is a raised to, applying plus x plus 0, 1 plus 1 plus 1 upon 3 raised to what, 1 by 0, infinity. That will be nothing but what, 3 by 3, 1 raised to infinity. Okay, this form. So now, such forms we need what, logarithmic transformations, right? So what do you do? You apply log 1 both the sides. So we have log of k equals limit as x tending to 0, log of a raised to x plus b raised to x plus c raised to x upon 3 whole raised to 1 by x. The powerful logarithm can bring anything down. That is log a raised to k is equal to k log e. Okay. So, log of whole thing inside a bracket is single function. A raised to k, once k 1 by x. Log a raised to k is k log e. Okay, fine. So, if you want, I write it here again. Log of a raised to k equals k log a. I will keep on repeating it so that it fits the apply. Okay. Now, again, applied log. So, principles of log. So, we have log of k equals limit as x tending to 0. Say, this will be log a raised to k log a. This will be log of a raised to x plus b raised to x plus c raised to x upon 3 into 1 by x. Into 1 by x means the x will come in the denominator. Yes. That's what we need. L'Hopital's rule. Fraction. Numerator by denominator. Okay. Now let's again check the limits now. See, again this will be, if you apply the limits here, what is the limit? 0. See, a raised to 0 is 1, anything raised to 0 is 1. So we have log of again 1 plus 1 plus 1 by 3 upon 0. So log 3 by 3 log 1. What is log 1? 0. So that is again 0 by 0 form. It is an indeterminate form, so we can happily apply the L'Hopital's rule here. And what does it say? Differentiate numerator upon differentiate denominator separately. Okay, so let's apply it here now. Now, first, so log of k is equal to limit as x tending to 0. Now, again, chain rule. Differentiation of log x is 1 by x. Okay, so log x, 1 by x, only log x. In place of x, what is there? A raised to x plus b raised to x is c raised to x upon 3. So, that whole thing is x. So, log of x 1 by x. So, differentiation log of this whole thing is 1 by log of x is 1 by x. So, 1 whole divided by a raised to x plus b raised to x plus c raised to x by 3. Right? Log of x is 1 by x. So, 1 by what is whole thing? Again, into differentiation of, what is that? Chain rule. Log of x is 1 by x. Again, if apart from x anything is there, again differentiate that. So, differentiate of again this a raised to x plus b raised to x plus c raised to x upon 3. See, this is one of the standard differentiations, but since it is not discussed many in many problems, we tend to forget it. You might have learned this in your 12th grades. We remember differentiation e raised to x, e raised to x only, but we do not remember what is differentiation of a raised to x. If you remember, if you recall it please, so I write here dy dx of a raised to x is what? A raised to x log e. Now you need to remember here only for this problem to get the marks. Okay. So differentiation a raised to x, it is a raised to x log a. That means the log of x 1 by x. So 1 by this thing, again differentiation this thing, it will be upon 3 as it is. A raised to x is what? A raised to x log a plus b raised to x is what? B raised to x log b. C raised to x is what? C raised to x. Okay, that's it. Whole divided by what is differential x? It's nothing but this is what I get. Okay, now I got differential 1 here down. So let's again apply the limits here. What is the limit? 0. So let's put the limit as set to 0. So we have this that implies log of k is equal to this. Apply the limit here. So this will be 1 upon, see again a raised to 0 1, put 0 here, a raised to 0 1 plus 1 by 3. Okay, into again. What is a raised to 0? 1. Log is a constant as it is. Again b raised to 0 1 log b as it is. This is log a plus log c. Am I right? Because c raised to 0 is 1, log c as it is 1 3. Right? Fine. Now this 3 and 3 cancels. What remains? We have 1 by 3 log of a plus log of b plus log of c. Now again you recall the one more property of logarithm, log of a into b is equal to log a plus log of b. What is that? Log a into b is log a plus log b. So log a plus log b plus log c is what? Log abc. Log a into b is, or log a plus log b is log a into b. That means log a plus log b plus log c is what? Log abc. Again this will be 1 by 3 log abc. Therefore what I can write here is, now I hope you are getting it now. Okay, what you can write here is, this is log of abc. Okay, so what you can write here is, that implies log of k is equal to, what is 1 by 3 log abc? Again log a raised to k log a. That means k log will be log a raised to k, because there is log here, I want log. Okay, I don't want anything attached to it. So 1 by 3 log abc, log a raised to k log. Here k log a is equal to log a raised to k. So 1 by 3 log abc is equal to nothing but log of abc raised to 1 by 3. Now here what happens beautifully, log and log cancels off. What happens? Log and log cancels off. So cancels, what remains? K is equal to abc raised to 1 by 3. That's it. That implies the solution is k is equal to abc whole raised to 1 by 3. That's all. This is the solution for this question. So the solution also is very, very beautiful, and the question is also very, very beautiful. So the solution for limit of x to 0, a raised to x plus b raised to x plus c raised to x upon 3 whole raised to 1 by x is what? abc raised to 1 by 3. Okay, so now see, sometimes the same question, no, they can repeat the same question using what many times do it. Okay, they can ask the same question, or what they'll do, they'll tell a raised to x plus b raised to x plus c raised to x plus d raised to x upon 4 raised to 1 by x. In that case, nothing will change, everything will be same as it is. Only one term d raised to x will be there. Then differential d raised to x is what? D raised to x log d. In that case, the answer becomes log k is equal to log a b c d raised to 1 by 4. So k is equal to a b c d raised to 1 by 4. They can do that. Okay, so practice the same question the same way. You can include here plus d raised to x upon the 3 log by 4 in there raised to 1 by x, and you can practice the same question yourself. That's it. Okay, if you practice it more, then you will 100% get it. Don't see it one time and leave it off. See the video, repeat it many times. It's obviously free. One time, two time, three time. Practice the question with me, and the fourth time you will definitely get how to solve it and score the full marks in the examination. I hope you will do it. Fine. So dear friends, that brings the end to this very important topic, the Heptah's rule. And the questions which are solved here are very important. They can be frequently asked in examinations. So please don't miss them. And also don't miss the previous videos which you can find in the playlist. I hope you understood the technique how to solve these problems. With more and more practice, this becomes very easy and can fetch you the full marks in the examination. If you like the way I teach, then please drop a comment below. Like the video, share it with your friends as much as possible, and please don't forget to subscribe. So thanks for watching. Stay strong, keep learning, happy engineering. See you in the next one. Bye.